Welcome back. I'm Matt Sargent with Efficiency Vermont. Today we're going up in the attic. We're going to talk about insulating and air sealing up there. We're going to show a couple different ways to air seal and create a good tight air layer to keep air from moving out of the building up into the attic. And we're going to show how the pros put a good thermal layer up there too. So come on along with me and let's take a look and see what's going on in the attic. Before insulating the attic, we need to seal up all the places where air can leak from the living space below. Warm air in the building has this tendency to rise, creating a chimney or a stack effect, which causes air in the building to leak into the attic through any holes or gaps in the ceiling. We're using a foam gun here to seal up electrical and plumbing penetrations, top plates, nailing blocks, basically any place where air can escape the heated part of the building. You can see Jeremy laying a big thick bead here on top of the light box. This is going to keep any air that's in the building from escaping out through that box. Here we're sealing up a big gap between two top plates, and boy, if you didn't seal that up, there'd just be a ton of air leaking out of there all winter long. Sealing the top plates to the sheetrock is real important because it keeps the air that's in those interior partition cavities from sneaking up past the sheetrock and getting into the attic. Here he's getting the top plates out at the outside of the building, another really important spot. In the background, we can see the insulation baffles. These baffles keep the cellulose from falling into the soffits and allow ventilation air to move out over the top of the insulation. Getting the nailing blocks, top plates, it's all really crucial to keep air in the building. So this is the bale of cellulose. You throw it up on the machine, open it up with the knife, get it right up in the hopper. The hopper breaks it up, blows it into the hose, and sends it out up into the attic. So this is 15 or 16 inches of cellulose in the attic, the finished product. You can see out at the end of the bays there that we're almost up to the top of those vent chutes. That's all the area that we filled in with cellulose. It's about R3.6 per inch. It gives us a total of about R50. Nice deep blanket of cellulose insulation. Sometimes there isn't enough room for the insulation needed to achieve the desired R value. This will be a finished room in the attic space above a garage, and here they're blowing closed cell spray foam, which has an R value of about R6.4 per inch to get the R value that they want. Now, spray foam is a great way to control air and vapor movement, but installing it should always be done by a pro. I'm here with Mark Brownlee, the architect on this project. Mark's with Hillview Design. Mark, we're upstairs in this high-performance modular home, and I see we got this smart membrane wrapped over the whole thing, and it's a nice big open space. What are you doing here?
Well, of course, it's a big open space right now. We intend to partition it off into 2 bedrooms, a bath, and a small loft area. So it's important. It was important for us to consider the membrane and that continuous air barrier before we did that, Matt.
So you didn't want any interruptions in the air barrier?
No interruptions. As it was, we had a possible interruption at our knee wall. At one time, we considered insulating across the ceiling, up the knee wall, and then into the slope ceiling and so forth. That was much more complicated, much more difficult to air seal.
Better to go continuous all the way out to the eaves then.
All the way out to the plate and to the eave and up and over and back down again.
Yeah, it looks great. Nice and clean. Nice and clean. It's easy to see how that's less than being interrupted by that. So in the sloped ceilings, how much insulation are we going to put in there?
Yeah, so our insulation, of course, is dense packed cellulose in the slope ceilings. Loose cellulose in the attic, R60 in the slope, R80 up above, and in order to achieve the R60 in the slope ceilings, we needed much more space available for the dense pack than a regular 2x10 would offer.
So the modular came with a 2x10 rafter,
That's right.
and you had to increase it?
Came with a 2x10. We had to increase that space for the insulation down to something close to 17 or 18 inches. So we did that by introducing some smaller rafters below the 2x10s, creating a space big enough to for the dense pack that's required.
So it's 18 inches of dense pack cellulose.
That's right.
Wow, that's a nice insulation package. That's great. Welcome back. It's insulation day today. You can see we've got our air and vapor control layer all detailed and taped up. In the background is Kevin DuPont. He's dense packing the sloped ceilings to R60. As Mark said, we're going to have R60 in the slopes, R80 in the flat ceilings, and R40 in the walls. This is cellulose insulation. It's 85% post-consumer recycled newsprint treated with boron as a flame retardant. It comes in big bales, and we know how much volume the bale will fill at the right density. You can see here you can compact this and increase the density of it, and that's what it's like when it's inside the wall. What we've got here is some great detailing on the knee wall. So this knee wall will have condition space behind it as well as in front of it. And what's happened is he's taken his air and vapor control layer and run it all the way out to the eaves and sealed it up out there with that sealed up blocking. Every place that a stud penetrates this air barrier has been sealed with this tape, and I can't find any holes in it. It looks fabulous. We've got the slope ceiling. It's been dense packed here, as well as the outside wall. But also this outer floor joist cavity has been dense packed, and you can see that's all really well done in here. And this goes all the way back the whole length of the building. It's great work. Thanks for joining us today. We were able to see flat ceilings and sloped ceilings. We saw minimum code level insulation that satisfies the RB's Vermont Energy Code. We saw super insulation, some intelligent membranes, and some other great air sealing details. There's lots of different ways to insulate and air seal an attic. Feel free to call us for information about your project. Till next time, I'm Matt Sargent with Efficiency Vermont.